So, hey everyone, FusedVR coming at ya.
Awesome.
And we got the voice of God. He decided to wear green to a green screen day.
Yeah, this is going to be interesting.
So, yeah, today, building, I think, probably my favorite mechanic once I finally found it, which is this stasis concept that if you played Breath of the Wild, which I've yet to play, I've seen videos, it's where you freeze an object, you punch it a bunch of times, or you slice it a bunch of times, and all of those forces get applied over like the frame of like 2 seconds. So it's a really cool thing. I'm going to show it off right now in mixed reality. Not sure how good this is going to come out, but we'll give it a shot. So
Yeah.
Here...
It definitely looks good when you're in the headset.
So I punched it way too much. There you go. Well, that's one punch. And then there you go. So you see... those forces get accumulated. I save the position of where I hit it and average that out. So I also just keep the rotations there, just that you can get a sense of it. Maybe if I hit it from this side. Oh, well, that blocked it.
Yeah. He hit it so hard that time it just flew off the screen.
But then my timing is off. There we go. But yeah, so I mean, if I light tap it, sort of. I don't want to put the headset on, but
yeah, it'll become too hard. But it's a fun mechanic. Also, definitely a big workout. We were just testing it around just for a few seconds, and I was getting exhausted from all of the punches.
So let me actually. I think it might also be better if I show this off in 2D mode or from the headset point of view. So let me throw this on. Get out of here. Oh, which cube is it? Oh, there we go. Send this out of here. Whoops. Bye-bye. Just need another one to spawn in. Oh. I think I might have broke it.
That may have been the end of it.
I think I accidentally caused physics when I shouldn't have. Let me do it from Unity. Let's just so you guys can see just a different perspective. Sometimes mixed reality isn't always the best way to show something off. Or at least not when you don't have
It's hard to get the perspective right.
Yeah.
I mean, especially when you're moving around a lot.
So 1, 2, 3.
Yeah.
You can see it flies. I'll light tap it. Well, so that force is actually, so I didn't actually counteract the force when it falls. So that's the force of it bouncing back up, which is interesting. 1, 2.
Now go ham on it. Hit it really hard.
Am I gonna hit you?
No, you're good. Yeah, so I think that's a good example. If you just hit it a few times, it's going to fly out a little. If you just go extreme on it and punch it a bunch of times, it's going to completely fly out onto the horizon. So, yeah, I think it's, like I said, one of my favorite mechanics, and
Breath of the Wild was honestly the first time I even saw that in a video game. So, pretty wild. And it really doesn't take that much to actually build, so I'm excited to actually build it out today. And let's get on the stool, and we're good to go. So, as always, gonna start a new project. Call this Zelda Stream, because I can. Give that a second. And so while the setup is going on, just kind of want to get a few announcements and talk with you guys a bit. So one, FusedVR was this week. Crazy week. Talking to lots of people. Thursday I almost lost my voice and I was like, this is not good. But I have it back now, so that's great. And let's go to the asset store while I'm talking. So it was amazing to meet all of you guys in person, and I just want to give a huge shout out to Chris Hind and Lex from New York. Spent a lot of time with them, and it's just an honor to meet you guys in person as well, just as much as you guys love meeting me, which is what was really exciting.
Yeah, totally.
Okay, so I want let's go to materials before I forget what I'm doing. Go to free. I just want the emissive pack, this guy. So yeah, if you guys are in the chat, say hi. And if you ever go to any events, and I'll post whatever events we're going to on Twitter, definitely come by, say hi. I love meeting you guys. it's really cool to see the community in person. It's one thing to do it online, but another thing to see people in person. And yeah, and then second, I think the big announcement I found out relatively late being a few hours after it was announced, was Palmer Luckey left Oculus, and yesterday was his last day. And I kind of want to, I'm not going to say anything right now about my opinion. I want to see what you guys think in the chat. I think it's a it's a pretty big bombshell type of announcement, right? So I'll monitor the chat. Hassan is in there with you guys already, so let me know what the community thinks, because
Yeah.
I'm interested in that. So getting this material pack, it's kind of big. I know, like last time, it's can take a while to bring in, and the reason is this material pack lets you use emissive, or one of them has an emissive property, which you might have seen in the intro, which is just like when we hit something, it'll light up a little bit, which is like just kind of a neat effect to have. Let's go ahead and import. And the other thing I want to do is, if you've watched our boxing tutorial, and I'll put a link later in the description, or maybe Abdo or Hassan can do that, then you can use the boxing gloves, which is just what I'm going to use since they're already modeled. We didn't have a lot of time this week because we were at the conference for the last 3 days, so most of this was actually made a while back, but I'm still excited we're able to show it. Something simple that just works. So once this is done, I believe I've already downloaded. Yeah, I already have the gloves downloaded, so let's bring in the gloves and the textures so that we have those. And the first step is just enabling physics on those guys. The second step is going to be actually applying the forces over time. The third step is we can play around with whatever effects we want to add, which I think is really cool. So let's close Asset Store. We don't need anything. I'd actually used a custom skybox, where I'm not going to do that right now. Let's just set up a really quick scene with just a cube and a plane to keep it simple. And game objects, 3D. Let's go plane, not quad. Plane. Set this to 0, 0, 0. And let's get a cube on here. 3D object, cube. Sounds good. Nice and simple. Add a rigid body. And that's our cube. And just make sure I didn't mess anything. Perfect. It just lands there. Oh, and I can't believe I forgot the most important thing, which is SteamVR. You go to the asset store and it's like, yeah, SteamVR is just kind of one of those things you might forget. But we'll get it anyways. And so we need that. And once we do, we'll just add the physics just to make sure that we can punch the cube. And we covered that for the most part in the boxing video. So that might be a little bit of a recap. If you want more details on physics and ragdolls and spring joints, which is I think all we covered in that video, you can check that one out. But for this purposes, we don't really need any of that. We're just applying forces. So this should come in a second. And you tried Tactical Haptics, right?
Yep.
Yeah, so I was trying their demo. They actually used, the reason I'm thinking about them is I'm seeing the longbow import, and they used that in their demo, which was really interesting. It felt very different than the normal longbow. Not in a bad way, but I guess it kind of felt like you're actually gripping the bow. So that was just interesting. So too many cool things to try on the expo floor, really.
Yeah. Oh my gosh, eye tracking.
All right, so we're gonna do more videos with eye tracking, but let's just say, oh, you didn't even try the foveated rendering demo. I tried foveated rendering with Toby.
But like how you?
It works.
You just like something that wasn't wasn't possible before works. Like how do you know that foveated rendering is working? So
complete tangent, but I think it's worth explaining because we're going to dive into eye tracking a lot in the future. Yeah. But basically, so the foveated rendering demo I tried was you render all of this pixels. You render like a pretty big section of the area you're eye tracking. You render a much or you render in high resolution. You render everything else in a lower resolution, and then they keep shrinking that on you. So you can definitely at some point, when the area they're showing you is a little small, then you actually notice like the peripheral of your vision being blurred and at a lower resolution. They actually also showed it to me at like, let's just render the whole scene at a super low resolution and see if that works. And I think when they did, I think it was about, they said it was like 2 megapixels of the screen were actually rendered in high resolution, the rest were low. I didn't notice anything at all. I think the max is, just for reference, I think is 5. That number might be wrong. I'm not entirely sure. Yeah, I think it is 5. Just thinking about like the resolution of a headset. Anyway, but like, so yeah, if you get about 50% and you couple that with eye tracking, you don't see the peripheral at all, which I think makes sense. Especially we've done like the vignetting with the faux shrinking, which you don't really see those edges if you play with it properly. So that was pretty cool.
So how did you know that it was working? I got busy with the chat.
They actually, so they just kept shrinking the area of which they were doing a high
Okay.
resolution.
Yeah, that
And
was
then,
it.
yeah, and then that was based on where you're looking. So, really good job. The company's name is called Tobii. Definitely go check those guys out. They're doing amazing things. All right, tangent aside. Sorry about that. I get excited about eye tracking. I'm gonna just enable our boxing gloves for punching things. So I'm gonna first add a script to call this boxing. Open that up, and for this, really, we just have to make sure the rigid body is tracked with physics. So for this, gonna create a private rigid body R, and then a public SteamVR tracked object hand, and then R equals, I'm being a little lazy with this. Obviously you can make this a bit more robust with null checks, but for our purposes we don't really care. And this we just have to say R dot, and sorry, this should be in fixed update. I sometimes forget this, but that's actually really important to like make sure everything aligns with the physics. Move position to hand dot transform dot position, and R dot move rotation to hand dot transform dot rotation. Keep everything in sync. Make sure it's fixed update. That's pretty important. We can even say we can update the comment just to make sure that works. And that's all we really need to make sure the boxing works. I'll go ahead, drag these gloves into the scene. Come on, there we go. And we have gloves left and right. Pull those out of the prefab because we don't need them there. One thing I will do is, because the rotations are off on these guys, I will parent these guys appropriately. So this is left hand. Make sure this is 0, 0, 0. That's great. Add a mesh collider on here. Make it convex. You just realized that?
Yeah.
Surprise! The stream is a lie. Make this kinematic. I'm just breezing through this right now for the sake of, we've covered this before and we just need to go through it for the sake of going through it, but to actually make things work. And while I'm at it, just delete the main camera. I just want to get to the cool stuff. That's really all I want to do. Right hand, and yep, cool. Mesh collider on you. Convex, inflate. I actually want to get rid of this rigid body. And then on these guys, we'll add our boxing glove here. And then we'll add a rigid body here. Make them kinematic. Sure, I actually accidentally hit Control S, but might as well punch. Just save the scene. It's not a bad time to do it. And yeah, then the only thing we have to do is add our references. So right hand, drag the right hand on there. Left hand, drag the left hand on there. And with that, let's just give this a shot in here. Turn the controllers on. There we go. Turn this guy on. And let's drag this to the side so we can just see the tracking. And it looks like I kind of already hit the cube off the side, off of there. So you can see they're not aligned properly. I also need to add the textures, but we can do that later. So what I'm going to do right now is just get the rotation down for the right glove, and it's the opposite for the left glove. So here, rotate that about so. So this looks like 90, 0, 0. Oh, I guess that's the left glove. You can play around with the position, but that actually kind of feels fine to me just looking at it. And so let's just apply that now that we're out of play mode. And did I? Oh, okay. It's interesting. It seems like they're backwards, but that's not a big deal. And 270 on the left glove. Not 270. Let's rotate that like so. Just want to make sure we get these numbers right because they're important to making it feel good. And then it needs to just rotate like so. So that seems like 0, 90, 0. No, 0, 90, 90. One more 90. 270 here. Alright. Yep, that looks right. Cool. So just keep those numbers in mind. And if you're following along, yeah, you can use these gloves and you just have to apply those rotations to make them make sense. So with that, I'm going to, well, I already hit them. Let's move the cube out of the play space just so that we don't accidentally hit it when we hit play. Okay, it is somewhere. There you go. So you can see that the physics is getting applied when we hit it, and that's really all we need to know to actually start playing around with making sure this is working the way we want. Now, before we get into the Zelda Stasis component of this, I do want to kind of make this look a little prettier. And for that, I'm going to, let me just quickly, yeah, it's this, no, not this guy. There's a material I like using, and like we said last stream, I do kind of think adding textures and materials, even when you're prototyping, just makes it a lot more fun and enjoyable to actually make things look cool. Let's drag this one onto the bottom, and then let's see if I can find the emissive real fast. There we go. So I'm going to drag this guy onto our cube. Come on, there we go. Make it a standard. May add the emission on here, and then instead of having a 3-3 tiling, make it a 1-1 tiling. So this is the kind of what you saw at the beginning of the stream, where the cube was already textured, and this is just using their asset pack. The area you see you can ignore because that's just a translation to PBR rendering. So yeah, so that's this. We got that working, and let's dive into what you guys are all looking for now that we've done all of the setup, and that is actually the stasis mechanic. So let's create a C# script, call it absorb hit. You can call it whatever you want, and hit reload. And here we have it. So on our cube, just so that we have a frame of reference, we'll be playing around with the rigid body. And so normally what you would want to do if you are taking over physics is apply kinematic. For our purposes, what actually happens is we're going to be using the void on collision enter event. I'll just pull that up on here. Go on collision enter. There we go. So we're going to be using this event, and in order for this to actually trigger, what you need to keep in mind is that you can't be is kinematic. That will actually cause this to not trigger. and you won't be able to apply physics. So, or you won't be able to apply physics, and you also won't receive what's happening to the object. So in our case, we want to be able to, when we hit it, we want to know that force that happens and save that for applying it later. And using just on trigger enter or its equivalent wouldn't allow you to get that information. So keep that in mind. I'm just going to delete this, and we're going to just start really simple. On collision enter, collision collide. There we go. So you're going to use this, and then we want, we eventually will get into adding like a manager that will allow us to drop cubes. But for now, what we're just going to do is allow all of that to happen in here. And for that, we actually do need a coroutine that's going to wait for 2 seconds. And in that time, you want to absorb all the forces and then apply them at the end. For that, we will need start. And we'll also need I enumerator, wait for forces. Alright, so this is what's going to get called. And just to make the compiler happy, I'll just do this for now. And these are really kind of the core methods that we'll need. We can add as many as we want. Like, for example, if we want to add a flashing to the cube or anything like that, you can add more methods. But we'll start with this for now. And here, what we want to do is let's actually we're going to need to save some variables. So the first being the force to apply. So let's call this total force. Set it to vector 3.0 for now. And the other one is the average position. This is also just going to be a vector 3.0 for now. And so the reason is we're going to be calling at the end of our wait force, we're going to be calling rigid body dot apply force at the total force of average position. So this is just a accumulated total. And we'll also actually need access to our rigid body. And here we'll just say R. Kind of wish they kept it, and I guess Unity 3 they allowed you to do. You can actually do this. You could actually do like this to get access to a rigid body if it existed. Kind of wish they kept it, but this might be a little more universal. All right, so we have on collision enter. What I'm going to do is just say total force equals collide dot impulse. So the impulse is what is the total force on that given frame, and you'll need to divide this by fixed delta time. And like I said, it's the force at that frame, and it's actually over a very short position. So by dividing by time dot fixed delta time, you'll be able to get the actual force that gets applied. I'm sorry, this needs to be plus equals so that you're accumulating that force. And then here, what we're going to do is for each collision point, I believe that's what it's called. It's in collide dot points is what we're looking for. And of course, it doesn't tell me right now. What is collide dot points?
It's an array, I think.
It's an array of.
I think points.
Is it just called points?
Maybe.
Or oh no, it's array dot contacts.
Yeah.
See, I clearly don't memorize it, and they're called contact point. Okay, there we go. So this is contact point CP and collide dot contacts. And for this, we're just going to go through every point that we collide with. Usually this is just one point, but if there are multiple, you can get them. And we're just going to say average position plus equals CP dot point. And for this, you actually might even want to do something like keeping track of the total points. And keep that to 0. And then we'll do total points plus in here. And so the reason is when you go to apply forces, you can just divide by the total number of points to get that average position. And so yeah, so this is just the starting point, and this is really kind of the base code that you need. You can add more stuff on top of this, but for the most part, this is pretty much done. We've calculated total force and average position. So now I'm gonna go into wait force, do new, wait 4 seconds. Let's go. I personally like 2 seconds, but if for testing purposes, I'll keep it at 3. I think that's a pretty good balance. And so we're just gonna wait for 3 seconds. For right now, it's just gonna be from when we spawn, but we can change that as much as we want. And so this is wait for force, 3 seconds, and at the end, we're just gonna do rigid body dot add force at position. We're just gonna do total force divide, and yeah, it's force and then position. So average position divided by total points. And that'll apply the force. We just need to go in here, and then the last part we need to do in order to make sure this all works correctly is do r.constraints equals rigid. For now, I'm just going to do rigid body constraints dot freeze all. You can in the intro, what we did was actually we just froze position. You can keep the rotation if you like. Doesn't really matter. Just for testing purposes, I'm just going to do freeze all right now. And then we just need to do start coroutine wait for forces. There we go. And the other thing, and I almost forgot this, is you just copy this line here and then change this to remove constraints. So freeze all needs to become none. And Visual Studios they really need to fix this. Where the fact that if you can I go in here and save? Let's just save that. Save all. Okay. For whatever reason, Control S stops working after a while in Visual Studios. I'm just going to close the editor for right now, just to make sure that's saved correctly. And yeah, okay, cool. And the only thing we have to do is really just add absorb hit onto here. We should be good to go. So you can see that the constraint gets applied, and after 3 seconds, it gets removed. So you already know that that's working. There's an error because I didn't actually punch it in those 3 seconds, and we will be able to fix that by adding in some timers to make sure that works. Just connect these guys and make sure I don't kill everything. Alright, set on. This on. Oh, I was like, I'm about to punch us on, actually. I was like, wait a second. Yeah, I saved your life. Let's put it that way. Alright, so it's right here. 1, 2, and there. That's that. I mean, we've got the basics of it already working. And that's really all there is to it. Well, that was lame. Yeah, I think I pulled back a little bit. Let's try that again. So one thing you'll notice is that it does kind of feel pretty weak. What I did like to do, and I closed the editor. What I do like to do is, sorry, that's the wrong piece of code. Let's go into this guy. Open that up. I like to actually apply a multiplier onto the force when we apply it. And so, okay, yep. So the total force here is going to be 5F. And it makes it feel a lot better than like that dinky push that you get. Oh, my controller lost tracking, but you can see that just when it starts flying off like that, it just feels so good. It does get tiring. If you've watched the boxing tutorial, I played what was it, Super Punch? So Super Punch was you move around, you punch and you move around, which is just so exhausting. It's like I'm like snaking around this whole room and like getting exhausted with every punch.
Yeah.
So there's something to be said about the punching style, like being, it just like, just I guess it's just like it is exhausting, and like that's one of the advantages and disadvantages of controllers. It allows you to be immersive but exhausting. There could be things where to make this even better, and I'm sounding as if we're like ending, which is not true. So I'm just thinking like to make this better, what you could do is maybe, I'm wondering if the buttons could be like a way of like, if you like pressed a button, it just sent out the punch from your controller.
Oh, what do you mean if you press the button?
So like I press the button and like kind of like a spring, the glove bounces back and forth.
So you like click to punch?
Yeah.
Yeah, I think that's cool. Another thing that I could think of is like I don't know if anyone here has played Red Dead Redemption, but they do a really cool thing where it's like, it's essentially like a bullet time type of mechanic where you time stops and you like paint a bunch of like shots that you're going to take, and then they all get applied at once, pretty much. So it makes me think you could also click not just the punch,
Like boom,
but
boom,
to select
boom, boom,
collision
boom.
points on an object, and then have them all get applied at one time. That
Yeah.
could be pretty cool. Especially if
yeah.
you, like, I imagine having like imagine a mesh that like could be deformed or deconstructed, and you click at certain places to have it, like if you could coordinate the collapse of everything in a fun way, that would be pretty interesting too.
Huh. Yeah.
Like take out the bottom first, then take out the top, or maybe the top then the bottom. I don't know. Lots of stuff.
Yeah, there's way too much cool stuff with time. That's the thing, right?
Huh.
If you play with time in VR, and we were actually like talking about this last night, it's just like you can mess with someone's like perception of time. Just
totally.
Which is just, we'll do a video later, I think, on like hacking the body with VR, which I think is just gonna be fun.
So on this point, I have to jump in. So we were doing a bunch of research on time dilation and how VR affects it. First of all, people tend to think that time passes by a lot slower in VR than in the real world. And summary, the reason why is that if your brain has cognitive overload and trying to understand the environment and interacting with it, then it stops tracking how much time has passed. So you could get somebody to do something for 50 minutes and they think it was like 30 minutes. Another thing, you can like manipulate the sun, and the way that the sun moves will get people to think that time's passing or stopped. The last thing that was crazy is that when the research that I saw, they said if you ask somebody to just look at a second hand, that second you will perceive as lasting longer than any of the other seconds. Like the first time that you do a task that is assigned to you, you perceive that as the longest of any subsequent task, because like you're focused on that.
Or like
moment.
if it's ticking.
Yeah, if it's ticking, you can try this out. If you tell somebody or yourself
Hold the clock.
to look at a clock and look at the second hand, the first second that you look at it, like, is perceived as longer than any of the other subsequent seconds. It's called chronostasis. And the general concept is that the first time you see it, you're more focused on this like event that's going to happen, and so your mind basically fills in more memory of that first time it happens than any of the subsequent seconds.
All right, let us know in the chat if you look at this thing and see if you like the first.
This is going too fast.
All right. Well, a GIF is all okay. Maybe this.
Yeah. So basically, it's gonna be hard with 1 second. They did it with a formal study, but again, the concept is that the first time.
There you go.
It's like the first time you look at the second hand, it's almost as if time stops for a moment.
Yeah, I kind of noticed it with this guy.
Yeah, that works because it's slower.
All right, let us know what you guys think of this. I can see a series of videos on time dilation or anything of that effect. It's just so cool, honestly.
So Hayden's chiming in and says that he finds that getting tired can add to immersion. I think
Yeah.
that adds into the overload stuff too.
Yeah, I agree. There's another YouTuber called Master Indie. Definitely go check him out. He started doing a lot of VR projects, and the reason I bring him up is in I don't know where he said it, but in when he made what's it called, Sword something, Sword Master VR. He designed it with the idea of like, I want you to always keep swinging and keep moving around, because that just adds to the immersion. And so there's, yeah, movement is great, time dilation is great, physics is great, and it's just playing around with any of those three or all three of them in any VR experience just makes a world of a difference. Speaking of which, what did the chat say about Palmer?
Oh, we could actually open it up now.
Yeah. Or actually, no. Let's wait like 15 minutes. I just want to get into let's see, with this. I mean, we have the basis of it down. Let's add it so that we have the spawning and it waits until you make the first punch. So, okay. So for this, what I'm gonna do is on this absorb hit, let's just make it so that it waits for you to punch before it actually starts the countdown. And the reason for that being, you want it to actually it's just kind of annoying to jump in and then it's like it happens already and it's like, what just happened? So I'm gonna make those things we added to start, I'm gonna put them right before our wait for forces. And okay, so that's good. And then for this on collide, what we want to do is create a boolean for detecting whether it's the first punch. So bool first punch.
We do have one request
for
an extension.
Okay.
So,
fire away.
Abdo and one other person, I think, talked about actually I think it's mostly Abdo. Well, it's kind of everyone's chiming in a little. So one concept that has popped up is making the object come back after you punch it.
You can punch on the other, or I guess, what do you mean?
Like it launches and then returns to its position.
Oh.
So I feel like the way we could do that, if we want to do it, is we would store the original position and rotation, and then after some time, just lerp it back to that.
Alright.
I mean, we could do something more complicated, like a boomerang, but that's going to be hard to implement in time.
Alright, but we'll try playing around with that.
Yeah.
That might happen.
That's just one concept. Keep it in mind.
Yeah, that actually replaces the spawner, which I kind of like. So
Yeah.
we'll do that. So let's first get it so that we can punch it, and then we'll take a quick break, and then we'll dive into that. I think that'll make a lot of sense. But I like that idea. I like that idea a lot. And I don't know if, yeah, just for being explicit on the stream, the idea is after you punch it, it flies, bring it back. So we'll do that. It's not, I don't think it should be that complicated. I might be underselling myself.
Yeah, we'll see.
We will see. Alright, so if it is the first punch, what I'm going to do is just check and make sure the other object that we collide with has a boxing component to it. And the reason being, that means it's one of the hands. So collide other component, boxing hand. Okay. And now if hand doesn't equal null, then we want to start this coroutine. So start coroutine this. And actually, this guy can get deleted because we don't want an infinite loop. Oh, okay. So we want transform here, which is fine. And then we just want to say first punch equals false. So that's it. Actually kind of works for that idea of bringing it back, because we can use some of this logic that we've already built in to do that. So we're just saying if it is the first punch, then make sure that we hit a, or if basically if we collide with anything, check if we haven't punched it yet, If we have, we skip it. If we haven't, then check that it's a boxing hand. If it's not null, that means it is a boxing hand. And so we start applying the forces, and we freeze the constraints, and then we just set first punch to false. So that, what we should see here is it hits the ground. Nothing should get applied until I actually punch it. So, alright, just turn you on. How do you feel closer? So, this guy, there we go. Notice, okay, there we go. So it's 1, 2, 3. And it flew up way over there. So I think part of the problem was my hand lost tracking. But as you can see, it waits for us to actually get there, and it's just a little bit more convenient as far as actually hitting it and letting the forces apply. So it's 10:50 now. I'm trying to think. I think it makes sense. Let's jump into the break, and then I'm gonna then let's tackle having it come back after a set amount of time. But yeah, just quick recap from after the break. What we did was we have the Zelda Stasis mechanic working. You can punch, and it only detects once you hit for the first time, it then starts applying all the forces. So yeah, that's where we're at now. In the chat, we've talked about after. Chat, give me a number for how many seconds you would want before it pulls back. I would say maybe 5 to 10 seconds, just to bring it back to its original position. And yeah, so let's implement that. That's a slightly different version than what we had at the beginning, but I think that's fine. That's the beauty of being live, is that we can actually do that. So for this, what we want to do is, I'm thinking, let's keep track of the rotation and position of everything until it gets applied back. So what we'll do is private list of vector 3s on position. Close new list vector 3. There we go. And let's do the same thing for with quaternions. Quaternions rotations. New list quaternion. Alright, so that's positions, rotations, and at this point we just need to record them over 5 seconds. And so we've added the force. What we'll do is keep track of time. So float t equals 0f, and while, I'm just going to do a while true for now. Actually, no, I'll do a while t is less than 5f. So that's 5 seconds. We'll do time dot delta time, and we'll do t plus equals that. So that'll accumulate to 5 seconds, which is nice. And we'll also, after that, we'll add a yield return new. Actually, no. Yield return null. So that just waits for the next frame. And so we're accumulating time, and then what we need to do is just save our position. So in positions, we're going to do add transform.position, and rotations, we're going to add transform.rotation. So, okay, so we have position and rotation saved as soon as we start applying the forces. And alright, so then what we'll do is we'll do this guy. So we'll do a for loop here. So for int, and this is now to play this back, is what we're going to do. So for int I equals 0, I less than positions.length, we know that the positions array and the rotations array are the same length. Positions dot count. Yeah, count. I plus plus. I never remember if it's length or position. Keeps changing from system to or like arrays versus lists, right? Yeah. All right. So that's that. And one thing I will do is just say is kinematic equals true here, so that we don't get physics applied while we're moving things around. And we'll just play this back. And actually, one thing I forgot is we're playing this back, so we need to go in reverse. So this is positions dot count minus 1. This is greater than equal to 0. I'm just reversing this array right now, and then I minus minus. So that equals positions at I, and this is transform dot rotation equals rotations at I, and then we'll wait for the next frame. So that applies that, and then let's just make a method for reset. Reset. And what this will do is, so total force equals vector 3.0. Average position equals vector 3.0. Total points equals 0. This is kind of boring, but we kind of have to call reset. That's a thing. We want to enable physics, so this becomes true, or false, sorry, so that's turned off. We want to reset our arrays, so this equals, actually, do arrays have a, yeah, we have a remove all, which is perfect. Rotations, I'm going to remove them all.
What's the high-level implementation plan?
So the high-level implementation is we add the force, we have a list of the positions and rotations, save those over 5 seconds, so we have a gigantic arrays for both.
Mm-hmm.
After 5 seconds, we then apply all of those in reverse, since we have the positions and rotations saved from the list.
Oh, this is after it's been shot out?
Yep.
Oh, so you're gonna save its 5 different points and then bring it back?
Yep.
Okay, cool.
So, oh, I can't, really? Fine. Is there no remove everything? If not, I'll just create a new list, but that kind of seems excessive. Let me just check real fast. If not, no, find exists. Clear. There we go. That should do it. At least that'll be a little more optimized. We do have first punch needs to be set back to true. And that should be it. I know I typed that out a lot and I didn't really explain it all that much, but let me zoom out the code a bit so that it's a little readable. So what we're doing is, I mean, we had all of this before, but now after we apply the position, we just keep track of everything in this while loop. We apply it in this loop, and then we reset all of our variables that we used here. Let's give it a shot. You want to do the honors?
Yeah.
See how much I goofed. Let's maximize. Play. Actually, actually, 1 second. I don't want to maximize so I can see both views. Alright, you got your gloves. There you go.
See.
You hitting it?
I think I hit it.
Alright, let's see if it comes back. After... I don't even know where it went, honestly.
Yeah, me neither. I could try hitting it again. Just trying to make sure that...
Oh wait, it came back. Right?
So it left.
Maybe,
I can't see it.
so it's kinematic still.
Now it's back.
Is it saving things? All right.
Oh, it's up there. I see it in the sky.
Yep, I see it too. So now it's kinematic, so it's coming. So it's. Yep. Nice. 2, 3.
It's always going up. Maybe I'm just hitting it in a certain way.
Hold on. Let me drop the amount of force that you apply onto it.
Also, how are you between those positions? Are you snapping it? The 5 positions?
I'm just replaying everything.
Oh, okay. Alright, let's see. So
Just do like like that. That should be good. All right. And whoop, whoop. Maybe I'll play it back faster. I think that would work better. That's the dinky fall off the ground.
should come back.
Yep, it's coming back.
Nice.
Sound effects for add effects.
Totally.
Yeah, let me play it back at like 2x speed, and to do that, for this, I just have to say minus equals like 2, so it skips some frames. Give it a shot.
Let's see. I'm hitting it up, which is why it's popping into the air.
Yeah.
I'll do these next ones so that it flies out.
Okay, maybe that was really fast. Oh.
You alright?
Yeah, I'm good. Yeah, you hit more of the chair than you actually hit the object. Alright, so that's flying. And it should be coming back. Yep, 2x
Yeah,
faster.
That's pretty cool.
That time rewind mechanic. Boof. I think that you hit it more down than.
Yeah. Alright, I'm just gonna hit this one really hard once it comes back.
Yeah, just do like one solid punch.
Sure. I'm gonna do a bunch of them.
I wonder if the stream saw that or heard that. There it goes. Maybe 5 seconds is too long.
Yeah, the sound effect is a nice touch.
There you go. Well, that's playing it forward and coming back. I think that feels a lot better than the actual like just spawning it after it goes. So good suggestion. I love it. This is why we live stream, so that I can do crazy stuff that I never even think about beforehand.
Yeah.
Awesome. Is there anything else people want to see as far like crazy ideas? One thing I didn't show, so I can show instead of freeze all, we can do freeze rotation, just so that you get see the rotations applied, and then everything flies off by itself. Let's give that a shot. Get your head as always.
A lot bigger.
Yeah. Alright, so here. Well, did I not apply? I thought I said freeze rotation. Let's check constraints. What did I change? Well, clearly no constraints were applied. So that should have waited 3 seconds before doing none. Let's check this out again. What in the world? Oh, sorry, not freeze rotation. I'm silly. Freeze position. And then the Vive slowly slips back onto my head. Alrighty. Did I hit play? If not, I'm just gonna. Yeah, okay, I'll do it from here.
Okay.
Desktop. This is a kind of a neat. Oh god, oh, that's what's happening. You can, if you put the Steam menu, you can bring up the desktop, which I think is just kind of neat fact. There we go.
Oh gosh. I'm definitely in the splash zone.
Come back. Maybe 5 seconds is too long. All right, 2. Okay, I want to add more force to it again. It's just kind of lame when the impulse isn't as strong as you'd like. Okay, let's maybe go 3F there. Bring this to like 3 seconds. 3 seems to be a good number. At least you can count to it. Just at least saying something. All right. And the reason you keep the rotation in, because I guess I didn't explain that, is just to add that little effect of that feels so good. That little effect of the cube is responding to it, so it's not just that you are getting no feedback really. It's more of like a diegetic UI type of thing.
Just to double check, so the implementation, because I didn't get to watch,
Yeah.
you're saving position and rotation frames essentially, or at each frame, and then unplaying or reversing that.
Yep.
Okay, so it's kind of like a keyframe type thing.
Yeah, exactly.
But instead of keyframes, it's every frame.
Yeah, I'm not interpolating at all.
Yeah,
well, I sort of am. Well, no, I'm not. Sorry. I'm not interpolating. I'm just skipping frames. When I play it back.
When you play it back, you're skipping frames?
I do every other frame to make it go 2x faster.
Okay,
yeah.
I see.
Yeah.
Yeah, okay.
And so you can make it even faster. So right now, so what happens is we would save 3 seconds worth of frames, which is a total of, can I do math? 270 frames. It should, if we like actually print out the length here, it should be almost exactly 270 or close to it.
270.
So 90 frames per second times 3 seconds. Math. Let's just, I'm curious to just see what the actual count is. And unplay, play. 1, 2, 3. So it should save, and the final count. I can't read that in here. What is it? 268. Yeah, pretty close. It might have skipped a frame or so, maybe from rendering, or maybe not. Like I've said in past streams, my computer is underpowered. For now, anyways. So it's just the problem with using laptop VR, but it is flexible. Yeah. So that's playback. Is there other ideas or that people want to see? There we can play with emissiveness, which I think is fun. That's what they do in Zelda.
Yeah, play with emissiveness for now until anything comes up.
Yeah. All right. Pop more ideas in. I wanna see more ideas. What are cool ways to make this even better? Because it's already fun as it is. That's when you know you have a good mechanic, when it's already fun and the stupidest form possible. So for this, what I'm actually gonna do is another coroutine. Enumerator, highlights. For this, what we just want to do is over like 1/10 of a second, just make it super bright and then drop down. And so we're going to get the renderer. So we'll need access to the renderer. So we'll call this, to the material. Call it M. And here it's just M. Let's get component renderer dot material. Yeah, all right, there we go. And then here, the start, we just need 2 colors. So one is the base highlight, which is going to be color.
Oh gosh.
What?
This is
Do we have a fun one?
It's fun, but so there's 2 so far.
All right. Talk to me while this is my basic code for like fading in.
So ideas that people have come up. I'm still waiting for Bakir. Clarify the idea you posted. Not sure I quite understand it.
Can you say that louder?
Bakir, clarify the idea that you posted. I don't fully understand what you're talking about on the post, but we do have 2 ideas from Dark Hallow and Mr. Grand Grind.
Okay.
Dark Hallow, his concept is to make the blocks or make the cube hit a wall of other cubes, and then
That's
when
easy.
everything reverses, it all gets rebuilt.
Oh, that's easy.
So even the
Okay.
wall itself would be
I just have to
rebuilt.
decouple the code, which is fine.
Yeah,
That's not too bad.
So that's one. Mr. Grand's idea is some visual feedback to demonstrate how much force is applied. So that might be like changing the color.
Alright, so we can do that, and yeah, let's do that. For the wall is not terribly complicated. I like it though, so we're gonna do it. So T is less than like 0.1f. So we're first gonna do the emissiveness. So I'm just gonna finish that up. And for this, it's just sorry, I didn't want the material.
The
I actually
third
wanted the
idea,
renderer.
we talked about this a little, FusedVR, is
Yeah.
making the box not static, but instead making it so that it responds to some of the hits in low gravity. So like you could hit it once, it will move. You could hit it another time, it'll move, and then it still gets all applied, but just seeing more feedback. Then Dark Hallow and Mr. Grind are just sharing a lot of love right now. And they're asking how you got so good with the Vive.
Practice. I mean, one year of putting out Vive tutorials gets you somewhere. And you just start with the simple stuff, and you make a lot of cool stuff eventually. Or I mean, it's not. I would say even this feels simple. It's just a matter of practice and thinking of cool ideas when you see them. I think. Yeah. What do you think?
I mean, I really think that it's that. Just practice makes perfect, and we're far from perfect, but we're definitely better than when we started. And also people coming up with cool ideas that make us think of how we would do things. Like your implementation of this, that's not what came to mind for me. But it's a faster, easier implementation. So
what did you have in mind?
I was thinking of just setting a timer and then storing like 4 positions and then separately lerping it back through them.
Oh.
But what I don't like about that approach is that with rotations it would be weird. Like it wouldn't play back perfectly.
Yeah.
It might rotate a different way than it originally did.
Yeah. I mean, it would be. Well, then again, you're only saving 270 points, right? So it's like not.
Yeah, so it's not bad. That's like I think that's the drawback of this approach, but really 270 points, like that's not.
I mean, we have 4 gigs of memory to play with.
We don't even have to save 270, right? Like if we were to, if we knew what our playback was going to be and we weren't dynamically adjusting it, we could cut that down.
This is also true. So, yeah, that's. I mean, yeah, we could save less.
This is a great solution. I like it.
It's simple.
Yeah, and it has a lot of, like conceptually, there's great parallels to just animation, which is awesome.
Alright, so T equals 0F. This one goes from end to start. And we should be done with that. Oh, I need to call it. So what I'm doing here is, oh god, I'm sorry. This is wrong. Or it's almost right, but it's wrong. So what I'm gonna do is unity change emissive color. So it's close. I'm changing the albedo as opposed to the emissive. So what we want to do is, I just saw emissive in here. Yeah, okay, emission color. So we're gonna copy this line, add that in, do this to here, and copy emission color instead of spec color, and this, and we should be good to go. Well, I also have to apply it to this line and reverse it, but that's easy. And start. Okay. Wait, why is it complaining? Returns the first intention semicolon? Where? Am I missing? You go to there, you go to there. Oh, okay, never mind. We're good. And we just need to call it up here. Ghost. So we're just gonna say stop coroutine highlight. This is janky. I don't recommend doing this in general, but or calling coroutines with the string name, just because you could run into issues later down the road. But for now, I mean, so the way you'd get around this is actually creating another script, but lazy. Stop, start. That should do it. And just to test it, we should see it when it hits the ground. Yeah, there you go. It happened really fast, and I'm not sure if the camera was going to capture it, but let me try hitting it just to see. Where are you? Yeah. So it's a very, I mean, we can make it faster as opposed to 0.1. I mean, you saw it also happen again. And I could also, what I could do is change the, instead of being white, maybe make it red. So here, so the end color, what I'm going to do is call it red. And that should make it super apparent. You can make it however, yeah. So now that's like clear as day that I'm hitting this thing. And then yeah, there you go. So that's that. Adds a little more dynamicness. The rotation helps, the color helps. The only other thing I could see us do is like a line renderer maybe for the indicating where it's actually going to go before it goes there. We can add that in. The other one was hit a bunch of cubes, right?
Yeah, and have them go back into place too.
Alright, so then maybe let's just let's create a script called how do we want to do this? So we want a script that's like reverse time, that like you have a record method and a playback method.
Yeah, and the record method gets triggered on collision enter, and then probably there's like a, well, I guess it would probably all be in a coroutine, right?
The playback would be. So let's try this out. I get to copy some of our code, which is convenient. And I mean, the reason we're doing a separate script is to
put it on the other boxes.
Yeah. So we just need this. Okay. We could.
We need to, as soon as it gets hit or starts moving, is when we need to start recording.
Yeah. All right.
So it's not when it's hit, because not all of them, or
we can.
No, they have to be hit to start moving. But oh no, that won't work. Because they could hit each other.
So one thing you can do is having them all play back at a set time. The easier way to do it was be like what you were saying is on collision enter. Like this might be just a script we apply it to only like cubes in the scene.
Mm-hmm.
In which case, like as soon as they're hit, they after 3 seconds they return back to where they belong.
Yeah, but how do we detect when they're hit? They have to be hit
on collision enter. Like you could do that.
But are we going for creating just one cube or a wall of them?
A wall.
Because the one issue that I could see is that they will have like minor collisions with each other to start the scene.
Which
like
is fine, right?
Oh
no, it's not. No, it's not. I lie. Yeah, you're right. Okay, so then let's write it the super generic way then, which is having a method that starts the play or starts recording, and then we have a method that stops recording or calls playback.
Yeah, so we need those regardless. It's just when to call them what we need to think about.
Which we can have the absorb hit do. And then it just has access to everything. That's one way of doing it.
Mm-hmm.
I need water. So let's have a bool here. Private bool recording. And then we'll also have update. So if recording, and we do we do what we did here, which is keep track of everything. And we already know that that's based on time. And then for playback, we'll have a separate bool. So this is set to false initially, and recording set to true here. And then this is playback. And then if playback, or actually for this I might actually do a coroutine, that might be easier.
For recording and playback?
For record, I'll do it in update. For playback,
I'll do playback, we definitely want to do a coroutine that we would start at a certain time.
And then I'll just do float speed. There we go. And for this, let's just copy what we did here. With this, we'll also have to, let's just keep track of. Actually, no, I'm not going to even bother with that. We'll have absorb hit handle that. So speed, and then instead of 2 here, we'll do speed. And for playback, we'll say start coroutine play at 2x speed. And we'll make it an int. Okay, so that'll handle playback. That'll handle record. And oh yeah, for playback, I'm just gonna set recording to false. And then we'll go into play. That should handle everything we need to, and now we just need to call these methods appropriately. So on you're gonna have your own playback, which is what we want. So let's create, instead of the lists, we can say private reverse time RT, and then in start we'll just get access to it. So yeah, I mean, I should preface this. I'm doing the cheaper way for the sake of the stream.
Yeah, I've definitely mentioned in here for the sake of speed we're getting a little hacky.
But the proper way to do this is with instances and having managers to keep track of what's going on. So RT, where do you go? So in here, okay, so we'll say here we're going to say rt.record, and then we can wait for wait 4 seconds, 3 seconds, and then here we'll turn off, whoops, here we'll turn off kinematic, and we'll say rt.playback, and we can get rid of this. We also know that should, I'll get even hackier. You know what? I'm going to get even hackier. Let's do this. You actually call play, and we'll do, ideally, yeah, again, what you would do here is actually do events. I think that would be the proper way to do it, but I'm going to be super hacky because I can. Do start coroutine, rt.playback. Did I spell it wrong? Start coroutine. There we go. rt.playback, and then the speed is just going to be 2. And then we can say yield return start coroutine. That's why it was being hacky, so we can wait for the coroutine finish, and then we hit reset. Oh, which means we actually need a reset method in here. So let's do that. Public void reset. And that's actually easy. We'll just say positions clear, rotations. I kind of like this ad hoc coding, I will say. There's just something unique to it when you don't actually prep. And for this, instead of this, we can just say rt.clear or reset. I called it reset. Yeah, I think that's it. We reset, we hit playback. The only thing we really need to do, record. So now I just need to, on the cube itself, add a reverse time method. There we go. And, or it's not method, class. Make sure it still works. Or as controllers, turn you on. There we go. That flies, and then hopefully it returns back. There we go. Alright, so we didn't break anything. Now we can add the wall now that we've decoupled it.
I didn't even get to see the implementation.
It's recorded. Let's copy this. Except on this one, we're going to remove absorb hit. Then build a giganto wall. Boop. Boop. Yeah, we'll just go. I'll have to make them smaller, or have less space in between for it to look cooler when when it explodes and reverts back. God, this time is so cool. I don't know. I don't want to get into relativity because there's just too much stuff there I don't understand. But I kind of wish I did understand. But it's just the fact that in virtual reality we can just play with things like time and it just works is so nice. There we go. Add that row in. Give it a good old duplicate. Push it up. Duplicate. Push it up. Duplicate. Push it up. That's just for physics' sake. Yep, that aligned properly. And the only thing we have to do, how do we want to do this?
Trying to figure out when to play them back.
Yeah, so what I'm going to do, since we have them parented, I'm going to be hacky. I like being hacky.
Put something on that.
We're going to here have a list of reverse time. We'll call it the wall. This is, sorry, a list of the reverse times. Gotta love hacking. Wall equals new list reverse time. And then in start, I'm just gonna get, we'll also have a public variable that's the wall. Public game object wall parent. So we'll set that in the inspector, and for each wall, for each, let's go with for each reverse time child in wall parent dot get components and children. We can just add that to our list now. Add child. So this saves me the time of having to assign everything manually to the in the inspector. So we now have that, and
How'd you end up doing it?
so I parented everything to the wall.
Mm-hmm. Oh, and then go through its children.
Yep.
Get the things.
And code. Keeping it hacky. Wall.add child. And then here, so for each reverse time child in wall child.record. So we can start recording for all of them. So this is where kind of I think the scene starts to get crazy. And That's fine, I think. Maybe.
Or what? Oh,
Yeah. First child. So now we call playback on these guys. It's just gonna get nuts. So we have the option here of waiting for everything to apply individually, or have it all happen at once, which I think is interesting. Child. I'm just gonna be more hacky. Turn off.
oh yeah, gosh, this thing's just.
This is getting like crazy, and I
yes,
like it.
It's not as simple as it sounds.
But that's fine. That's where we thrive.
I mean, like thinking about it, if we were to do this really properly.
Oh yeah,
I
there
feel
would be
like
events and
it's its
like,
own stream that like is
yeah.
a hefty stream. So it's
Just
crazy to be doing
kinematic
it on the fly.
is true. And then
At the end of the playback, we set it to false.
yeah.
It's rough. Or just in playback, we should set kinematic. Or oh, what is this? Oh, absorb hit. I see.
Maybe I should do it here. That might make sense.
Yeah,
All right,
when
we'll do
you're
it here.
going through it. Probably easier.
This is rigid body R equals get component. I don't know. Rigid body get component, and then we have that R dot is kinematic equals true, and then here we get to say it's false. Alright, so now I don't have to worry about it in here. I don't even have to worry about it for this also, which is kind of nice. Don't have to worry here. So now we do it for all of the children. We don't have to do it here, and then we do it for ourselves. Am I forgetting anything? I'm gonna do clear at the end of playback. This is just like me like saving lines of code. I think that's the best way of describing this. Okay, so now we don't have to call reset here. Or this, actually.
When do they actually, what triggers the playback on all of them?
It's 3 seconds after the cube flies through.
So when do you detect the cube first flying through?
It's 3 seconds. So it's 3 seconds. So okay, let me walk through this.
Yeah.
So
let's give a high-level overview for everyone that's in.
So this is basically what's, if you're tuning in right now, this is basically the state machine that really should be that should really be in another class, but
yeah,
that's okay.
Totally.
So what we do is the scene starts. We sorry, not scene. Yeah, okay. Scene starts as soon as I go to punch that cube. I disable physics on its position. We wait 3 seconds to accumulate a bunch of forces. At that point, we apply all of those forces to our cube, and we record the position of that cube for the next 3 seconds, as well as the wall that we just created. Once we do that, we are recording for 3 seconds, so that's this line right here. After 3 seconds, sorry, we don't need this anymore. Good call for making me go over this.
Yeah. Good idea.
After 3 seconds, no, I do need it. Sorry, never mind. After 3 seconds, we play everything back, so it reverses in time for everything, and then we reset the scene, and we can keep doing that for however long we want to stay in the experience. So, assuming I did everything correctly, which is a pretty big assumption, because I was just like thinking, talking.
Yeah.
Let's give it a try. Into VR we go. On controller.
Wait 1 second.
Am I gonna kill anyone?
No, you have space.
All right. Here we go. Boosh. Alrighty.
Yes.
Boom, 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 boom. Boosh. No, it didn't come back to the right place. That's okay.
Yeah, it's so there's a little something off there, but
Oh, I think it's skipping the last frame. That's why. Oh, I didn't even
here,
press that.
let me
hard.
just restart it.
Yeah, can you play it back in the script at 1x speed?
Let's see.
So I think, yeah, those 2s, can you replace them with 1s?
Yep.
It's gonna be slow, but I'm willing to wait 3 seconds. That's the thing. This came out a lot cooler than I thought it was gonna be.
This is a good suggestion and a lot of good freestyling too. I think you'll need to back up.
Oops, I hit it from the side.
Just let it come back.
I'm using the force. Whoosh.
Oh, this one should be good. I think that what's happening is when it comes back.
Oh,
Nice.
oh, it might be.
It hits them on its way back.
I thought I turned off physics though. Maybe I did. I not?
Well, you turned it to is kinematic, so yeah, that should be turning it off. Wonder why would it? Maybe it's skipping.
So
Might just be like an off by 1 type of error.
it's greater than equal to 0. Then we do it, and we go back based on the speed. It's kinematic. Or maybe I'm not hitting record at the right time. Or maybe I should call record. So maybe let me maybe it's just like missing that initial punch. So I'm gonna hit call record here. I'm gonna wait a frame. Field return null, and then we'll start adding the forces, so that we get the save the initial position for sure. Then we wait 3 seconds. Then we reverse everything.
Yeah, I mean that should work.
Believe. If it doesn't, there are problems. That's okay. Ooh. Bye bye. And yep.
Nice. So one request is to just make the cube bigger and give it some more mass, so that it hits.
All right. So let's add some extra force in there and then more mass.
All right.
Let's make all of these guys like 0.1, and then that cube 2 by 2 by 2. I actually might need to make this plane bigger also, just so that things stay on the ground. Let's go 5 there. Let's move the wall back a little bit. This is going to be a little bit back too, so that everything's in the play space. And the mass, I'm going to go with, oh, we could play with physics materials here for days, honestly.
Yeah. That would be a lot of fun.
Like adding extra bounce. Oh, God. I'm not going to because I might. We do have some time. Whoosh. Hi. Drum roll, please. Oops, I think I went too fast. And where are you coming back from? All right. Boom, boom, boom. Boosh. Feels so good. Dunk. Boom, boom, boom. Boosh. I could be here forever. It feels that good. It's such a good mechanic.
Nice.
Let's go here. Boom, boom, boom. Oh, that was lame.
What happened there?
I don't know. Maybe I just didn't save it properly. You just got wrecked.
Thankfully, I don't fly like this cube.
Yeah, I totally like. I definitely just hit Hassan like really hard. No one saw it on stream. No one knows your agony.
Yeah, I broke a rib.
Bye-bye. So, what was I gonna add?
I don't know. I think that was, so there were just different requests, but I think that they're all pretty tangent to that. We did color feedback. Someone asked having 6 small cubes, which you hit only one time. Not sure what that means.
I mean, we can duplicate our own cube here. I'm trying to. What did I say? And I don't have the video on. Like, I'll go back in the video and I'm gonna like be like, why didn't I think of that? It was the playback. Oh, physics materials.
Oh yeah.
There we go. Let me. I think we we need it on everything, but let's just create one that's just like
Oh, that should be doable.
the bouncy one. Very little friction there, and super bounce. Maximum. Let's just select all of these cubes. Bouncy there, and then bouncy here. Let's see how that looks. They all share the same material. Oh God.
Someone just. Oh, dude, that's nuts.
Okay, maybe a little too bouncy.
Yeah, I think they're also just like they can't assemble anymore.
Yeah. Okay, fine. Let me get rid of that on at least those guys. I'll keep it on
So someone's request was just to try out multiple big cubes that you hit.
oh, like here. So
Yeah.
I don't know if I made this too hacky or not, but hopefully this works.
Yeah, if it'll work.
At least it would be fine if we didn't add that like reverse time in.
Yeah.
I might just have to be careful to make this work. Okay. What in the world? Look at this. They're like dancing. It's like a disco rave. Alright. Alright, go. Whoosh. And come back. Alright. Oh, that guy got hit. Something happened. I don't know. Now he's like dancing really crazily. What in the world is going on?
I don't know. It's like playing back itself.
Alright, let's try it on 2 different cubes. So let's start here. Is there anything in front of me?
They're all dancing.
Yeah, because I made it bouncy.
Oh. Well, that probably has to do with like is the collision with the plane triggering a record and playback?
It shouldn't. It should be looking for my hands.
Oh, okay.
Alright. Bye-bye.
That one went up. The one on your right has stopped playing. Oh wow, came back.
Oh, jeez.
This is just absolute mayhem.
Alright, let's try that. Shit it. I don't know what just happened. It flew back. Well, that's physics materials.
Yeah.
Doing crazy things. We'd have to play around with this for a while. It's just so fun.
Yeah, totally.
So
Anything
fun.
with physics, and this is also super impressive that you just hacked this all together on the fly. Way to go.
That's what I do, right? Yeah, we're close to 12. I haven't even gone through the chat other than like during the break, so I want to pull that up.
Yeah, let's just do a review of that. Close it out.
Hey, there's John. He's awake. Alright, so let's go all the way to the top. I'm gonna message you. I have an amazing idea. You can message us on Twitter or YouTube or really any of our social media. That's just a great way to get to us.
Yeah, I'm already talking with them.
Jack Collins. Dragging cursor is obvious. Eye tracking is healing the typical programmer problem when you stare at a screen the whole day. Did you guys talk about that? Oh yeah, Abda actually brought it up. Yeah, as far as eye strain is concerned, you actually, when you went into the eye tracking, you tried to strain your eyes a little bit.
Well, I was juggling with my eyes, so that was like just way more eye movement than I'm used to.
Oh, yeah.
But that usually would, in most experiences, that wouldn't be the case, right?
Yeah.
Like,
Yeah, that's true. I just feel like foveated rendering will make it just that much better. I wonder what effect that has on my eyes. Research. Okay, got my vibe mostly because I want to do some neat dev things. Nice. The vibe is solid for deving. That's what we said in our talk, which I really agree with. They inject the stream directly on your retina. Oh, Magic Leap. Magic Leap. I just want them to come up with something, honestly. Ba-do. This little life hack. Add scene, load, reload the scene to grip press. Yeah, I feel like we can. Well, I would take a look at our SteamVR load level tutorial. We can hack that in. Like, you can use that to hack in grips to make that work. Boomerang would be sick. Yeah, the reason I'm going through this, in case this is taking time, it's just because the chat is honestly what makes the live stream that much cooler than anything else. So I think it's worthwhile sharing that with everyone. 5 trackers, I just don't know what to do with them, honestly.
well, we did fun stuff. If we have them, I think we could do a lot of fun stuff.
Yeah, we can. I just don't imagine investing in them anytime soon.
If
Maybe.
we got some. Though.
If HTC, wink wink nudge nudge. Yeah, then we could. I love this right there. Paul come into work to VRTK. Mix of time. We did that, so that's sick. Boop-a-doo. I didn't know you can retract messages here. That's legit. When you hit a bunch and it didn't fly, I thought that was unintentional.
Stone Fox mentioned you can use Vive trackers in VRTK now.
Nice. Yeah, in case you guys didn't hear, because Hassan is like off to the side, Vive trackers worked with VRTK, which is legit. Slowing time with this. So much time hacks could go on. Yep, we were very hacky. That is a fact. Udacity, I saw. Tilt Brush is what? Close to 13,000 subs. That's legit. I have not played Sorrentino VR. Have you?
No.
That's the sword game, right?
Yep.
Actually, I didn't try this, but I don't remember the name of the game. Actually, I think he has watched the stream, but it was this really cool thing where it's a VR game on rails. You have both hands that are swords, and then when you put them together, they become a bow and arrow.
Oh, that's cool.
Which is like, it lets you switch really easily between like melee combat and like ranged combat. Yeah. So you can do a bunch of stuff with that. I think that's a really neat concept. It looked beautiful, and I'm totally blanking out on the name. This is one of those things where I met too many people, and then I just don't remember everything that went on, and I feel bad about it. Lean detection. If you have tracks with slow-mo shooting. The breakable objects. Oh, yeah, that would be cool too. Breakable objects. Cool. Yeah. This is awesome. I love seeing an active chat. It's great. So I think that pretty much wraps it up. I appreciate. I know this is April Fool's Day, so I appreciate you guys spending our time with us. This was not a fool's
Definitely
idea.
Not a fool's idea. This became really. I mean, it was awesome to start off with, but just for everybody towards the end, it started as a stasis mechanic, but now we're kind of getting into like a rewinding time mechanic, which I mean we'll definitely be playing with on more videos and streams.
Yeah. Like I said, we really think physics, time, and just locomotion are just like some cool ideas for VR.
Totally.
So yeah, that pretty much wraps it up for this video. Thanks again to everyone who came by, and if you haven't, although I feel like most of you watching this right now probably have, you can like this video. That helps us out a lot. Check us out on social. That works too. And that pretty much does it. So
Yeah.
this has been Fuse, man.
Awesome.
We're signing now. Guys, later.